Good day, viewers. Welcome to Francis Aundave Learning Space. Today, we'll be looking at indices. Now, under indices, we'll be looking at how we solve problems on indices with their bases not being the same. Just like on the board here, in A, you realize that the base here is 3, the base here is 4, the base here is 1. Here, the base is 3, 10, 3, 9, 8, 5, and so on and so forth. How do we solve problems like this? Now, I'm sure we are all familiar with this way. When we have an initial problem like 2 raised to power x equal to 4. Now, what base must we raise 2 to get a 4? 2, right? So this is 2 raised to power x is equal to 2 raised to power 2. When the bases are equal, you pick the powers. So this is x is equal to 2. Some text will have it to be, you cancel out the bases. Whichever approach you use is correct. Are you following? But today we are looking at something more interesting other than having the same basis. When we have problems like this, let's look at it. First, solution. We have here A, we have 3 raised to power 2x plus 1 minus 4 into 3 raised to power x close bracket plus 1 equal to 0. Whenever we have a problem like this, first we have to simplify this. We have to simplify the powers. Here, this can be expressed as 3 raised to power 2x times 3 raised to power 1. This 3 raised to power 2x, this plus means multiplication, 3 raised to power 1 minus 4 into 3 raised to power x plus 1 equal to 0, right? So this can be expressed as well as 3 open bracket, this 3 now, this is it, 3x raised to power 2. I'm sure you remember the law of indices that states that whenever we have something like a raised to power m raised to power n, this is same thing as a raised to power mn. I'm sure you're familiar with this. Thank you very much. So from here we continue. This is minus 4 into 3 raised to power x plus 1 equal to 0. Now, we cannot solve this directly because the bases are different. The base here is not the same thing with the base here and this, although this base now looks same as this base inside, but this 4 is not same as this 3. So this is what we do. Since we've simplified this 3 raised to power x now, we can say let p equal to 3 raised to power x. So anywhere we see 3 raised to power x, just substitute it with a p. What am I talking about? This is it. So this is 3p raised to power what here? 2. Why? Because this 3x here is represented by p. Thank you. Minus 4p. This 3 raised to power x here plus 1 equal to 0. So you see, we've arrived at a quadratic equation. Now, whenever you arrive at this point, whatsoever method you prefer to solve your quadratic equation with, please feel free to do that. So let's use factorization method to make it shorter and easier for us. So first, let's multiply this term to this term. 3p squared times 1. This will give us 3p squared, right? So let's look for two numbers that when we multiply, we get 3p squared. When we add, we get 4p squared. That's a negative p and a negative 3p, right? So we bring this down, which is plus 1. We bring this down, which is 3p squared. I'm sure you're following. Good. So let's just quickly complete it here. So I'm rewriting this. For those of you that are taking your SSCE, please, I will advise whenever you come to a dead end like this on the page, when you're moving to the next page, you write the step you stop at on the fresh page you're going to. So this will be 3p squared minus p minus 3p plus 1. So let's pick this and this, we factor them. So what is common here? P. P into, p here we have what? 3p minus p here we have 1. What is common here? A negative 1, right? Minus 1 into, minus 1 here we have 3p, minus 1 here we have minus 1. So this is same thing, the brackets are the same, so we'll pick what is outside. This is p minus 1, p 3p minus 1 equal to 0, equal to 0, equal to 0. Please, we all set them to 0. So let's equate the individual brackets to 0. So this is p minus 1 equal to 0 and 3p minus 1 equal to 0. So here we have p is equal to what? Is equal to 1 and p is equal to 1 over 3, right? So these are the values of p. So now we come back and say, but p is equal to 3 raised to power x. Are you following? So now when p is equal to 1, we substitute here, we substitute it here. This is 1 equal to 3 raised to power x. And what power must we raise 3 to get a 1? 0, right? So this is 3 raised to power 0 is equal to 3 raised to power x. The bases are the same, so equate the power. So x is equal to 0. Or, now when our p is equal to 1 over 3, we still equate it here. But mind you that p is equal to what? 3 raised to power x. So this is 1 over 3 is equal to 3 raised to power x. The same thing as 3 raised to power negative 1 is equal to 3 raised to power x, right? The bases are the same, so we pick the power. So this is x is equal to what? Negative 1. Therefore, our x is equal to 0 or x is equal to negative 1. This is how you solve problems like this. Are you following? So let's look at B. So B, we have 3 raised to power 2x minus 10 into brackets 3 raised to power x plus 9 equal to 0. When you have a problem like this, let's simplify the powers. This is same thing as 3 raised to power x raised to power 2 minus 10 into 3 raised to power x plus 9 equal to 0. So let's use y now instead of p. Let y equal to 3 raised to power x. So let's substitute here. Anywhere we see 3 raised to power x, we replace it with a y. So this is y raised to power 2 minus 10y plus 9 equal to 0. So please, I'll be fast on this one because we've had an example like this before. So this is y raised to power 2 minus 10y plus 9 equal to 0. So by factorization method, we multiply these two, we get, by multiplying these two, we get 9y squared. Now, two numbers that won't multiply, we get 9y squared. I won't add, we get this. This is a negative y and a negative 9y, right? So you bring this down, this is plus 9. You bring this down, this is y squared, equal to 0. Let's factorize this. This is y into y minus 1, right? Let's factorize here, minus 9. This will give us y minus 1 equal to 0. So when we solve, you realize that your y is equal to 9 or y is equal to 1. So now, but mind you that our y is equal to 3 raised to power x. I'm sure you're following. So when y is equal to 9, we substitute here. We have 9 is equal to 3 raised to power x. So this is 3 raised to power 2 will give us 9 equal to 3 raised to power x. The bases are the same, so we go with the powers. So this is x is equal to 2. Now, and when y is equal to 1, we substitute here into y is equal to 3 raised to power x. This is 1 is equal to 3 raised to power x. Now this is 3 raised to power 0 equals to 3 raised to power x. This goes with this, whichever way you want to go. So this is x is equal to 0. I'm sure you're following. So this is how we solve problems under indices when their bases are not the same. please, a lot of you will see this when you're writing your SSCE, such as WAEC, NECO, or NAPTEP. So please put it at the back of your mind. Just practice, practice, practice. It is very easy. This is something you can do. And with this little knowledge, I want you to attempt C and drop your answers in the comment section below. I will be there to look at it and give you the necessary corrections, and also verify if your answers are correct or not. So thank you very much for having me on this platform. I remain Francis Aundavi. I love you raised to power 2 plus 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 plus.